All right, so let's take a look at another student question on kinematics here. And this is a pretty tough projectile motion question. It's a lot easier to solve when you learn a later topic called work and energy, but we're going to solve this using a kinematics approach. Now, these are the kinds of questions that my students have asked me either in the past, or if you guys have any questions, you can submit it to questions@bothellstemcoach.com. It's in the description below, and I will try to pick your question and answer it. So let's take a look at this one. So we have an object is thrown with a fixed initial speed at various angles relative to the horizontal. So we're launching it at different angles at some constant height h above. So here's the distance h, and we're launching it at different angles here. So speed v0. Notice that it's very symbolic, right? Like I still teach this process. This is sometimes a little bit tricky. Is even with symbols, we're going to do the same process. Okay. Which of the following best describes the dependence on v and alpha? So v is the let's see, what is above the launch point speed? Oh, this is the thrown with a fixed initial speed at some constant height above the launch point is measured as a function of the initial. Oh, sorry. Some launch point. My bad. I butchered this question. So it's going to come some point. At some point, some constant height above the launch point, as speed is measured as a function of the angle. Okay, so let's say there's some point, not necessarily the max height, some point here. We're going to measure this height as h. And I would like to know what this velocity is and how it compares if I were to change the angle, but still at the same height here. Okay, so again, this is kind of the setup. So I want to know, I want to understand what the velocity is. That's what I'm solving for, right? And I want to see how that dependency works on alpha. A lot of people think like because we're not solving for anything, we shouldn't do any analysis. You should just sort of conceptually know the answer to this question. That's not true. We're still going to follow the same process. Okay, we're going to look at the x and the y. Now, what I want is, because I want the velocity at a particular height, I want the final velocity for both the x and the y. I do need to know both of these, like this one and this one. Okay, because I need the x and the y component to find that total amount there. Okay, so let's look at the horizontal displacement. I don't know the horizontal displacement. I do know the vertical. Oh, we got to set directions. We'll say up is positive, right is positive. I do know it goes up from here to here. It travels a vertical distance h. Okay, now be careful. Like I drew the arrow kind of like that, but let's make this arrow a little bit different. Let's make it like this, and the path just happens to go through there. Okay, so it's not like that makes this h makes a right triangle with this v0. Okay, so that's what we know about the displacement. I don't know this guy. How about the initial velocity? Well, I have to decompose it into two components, right? And make it, because this is up and to the right, I make it, there's a right and an upward component. v0 cosine alpha, v0 sine alpha. Okay, so then this thing is moving to the right at v0 cosine alpha, which is positive. This thing's moving up at v0 sine alpha, which is positive, and that's in the y direction. Cool. Final velocity. Well, I know horizontally the acceleration is 0, so I do know what this is going to be. And this acceleration is negative g. I don't know this guy. I do want to figure them out. Okay. And then finally, the time, I don't know the time in the air. Now in this one, because I want this guy, I'm going to pick the equation that relates these four variables, right? The thing that I'm looking for and the quantities that I kind of like listed or described in the problem here, right? So I'm going to use this equation because this is the one equation that compares those, that relates those four variables. So that's going to be v squared is going to be v0 squared sine squared alpha. I'm just squaring v0. Plus 2 times h, or sorry, 2 times negative g times h, because the acceleration was negative g there. So that's v0 squared sine squared alpha minus 2gh. Okay, so that's what I get there. That's where we'll just leave that alone. And then we know that this guy here in the x direction is v0 cosine alpha. Now we're asking about the dependence of v, which is the speed. Speed's going to be the magnitude of the final velocity. So what we know at this point is that this vector v, all I know is that right now it has a horizontal component, v0 cosine alpha, and it has a vertical component, this guy, the square root of that guy, because it's a v squared. Right? That's what we've determined so far. Okay, so I want the magnitude. I want the hypotenuse. So I'm going to use Pythagorean theorem. So I'm going to say v squared is this squared plus this guy squared, right? Oh, I'm sorry. This is not supposed to be negative g. I made a mistake. This is positive g. Why is it positive g? Because, no, it should be negative g. Sorry, my bad. Negative g, because I said down was negative. Okay, that's fine. Yeah. Minus 2gh. Okay. Sorry. I had a brain fart there for a second. Okay, cool. Now you'd be like, okay, it's like, all right, so like, remember, we're trying to figure out the dependence on alpha. But here's a trick. I can factor out this v0 squared, and you guys are supposed to know from your pre-calculus. You may not know it yet, but sine squared plus cosine squared is actually equal to 1. Right? That's one of your trig identities. So what you get here is that v squared, the final speed, is only dependent on the initial velocity and the height. There is no dependence on alpha. And so the answer is it will remain constant independent of alpha. Now, a lot of people get confused on this because they're like, well, are you just supposed to know that? Are you supposed to memorize that? No, you're supposed to follow the process. It's just you have to interpret what the meaning of the answer is, and you have to interpret the result that you get. And that can be very tricky for a lot of people who are used to like doing the textbook style problems. But College Board loves to ask you these kinds of questions. Maybe not quite as analytical as these, but these kinds of quote unquote conceptual questions, they like to ask them. But honestly, it still requires a great deal of analysis. It's just you have to understand what the analysis, what that process results. This process that I just used is identical to what I teach for all my projectile motion problems. I do the exact same way with this process. It's just I have to interpret what the equations tell me in the end. So if you guys have any questions that are coming up from school or anything like that, feel free to send them to me. I'm happy to answer your guys' questions.